Today we're deriving this equation, the velocity initial of object 1 minus velocity initial of object 2 equals velocity final of object 2 minus velocity final of object 1 for perfectly elastic collisions. We do this by stating two laws that are used in elastic collisions: the conservation of momentum and the conservation of energy. Conservation of momentum states that momentum initial equals momentum final for both objects in a system during a collision, which means mass 1 times velocity initial 1 plus mass 2 times velocity initial 2 equals mass 1 times velocity final 1 plus mass 2 times velocity final 2. Now if we subtract this over on this side and this over on this side, we can write mass 1 times velocity initial 1 minus mass 1 times velocity final 1 equals mass 2 times velocity final 2 minus mass 2 times velocity initial 2. Now we can factor out the common masses from both of these sides. Mass 1 times velocity initial 1 minus velocity final 1 equals mass 2 times velocity final 2 minus velocity initial 2. Now, we move back over to the other side with energy. We know that in a perfectly elastic collision, the kinetic energy is conserved. So kinetic energy initial equals kinetic energy final. 1/2 mass 1 times velocity initial 1 squared plus 1/2 mass 2 times velocity initial 2 squared equals 1/2 mass 1 times velocity final 1 squared plus 1/2 mass 2 times velocity final 2 squared. Here, as you can see, all the terms have a half. We can cancel all the halves out. So we're left with mass 1 times velocity initial 1 squared plus mass 2 times velocity initial 2 squared equals mass 1 times velocity final 1 squared plus mass 2 times velocity final 2 squared. We'll do the same thing we did on the other side. We'll bring the like terms with mass 1 on one side and subtract over the ones with mass 2 on the other side. There we can write mass 1 times velocity initial 1 squared minus mass 1 times velocity final 1 squared equals mass 2 times velocity final 2 squared minus mass 2 times velocity initial 2 squared. Once again, we can factor out the like terms on both sides. So we're left with mass 1 times velocity initial 1 squared minus velocity final 1 squared equals mass 2 times velocity final 2 squared minus velocity initial 2 squared. Now we bring both of these equations together, this one and this one. You can say that this expression over this expression. Now on both sides our masses will cancel out and we're left with here's a little trick that people often forget. This is the difference of two squares. You learned in math, which is a squared minus b squared essentially equals a minus b times a plus b. So you can split both of these terms like that. So it would say velocity initial minus velocity final of 1 times velocity initial 1 plus velocity final of 1 equals, same on the other side, velocity final 2 minus velocity initial 2 times velocity final 2 plus velocity initial 2. All over velocity initial 1 minus velocity final 1 equals velocity final. As you can see, our like terms will cancel out, like so, and we're left with the equation velocity initial 1 plus velocity final 1 equals velocity final 2 plus velocity initial 2. Now once again, we can bring our initial velocities to one side and our final velocities to one side, subtracting this over here and subtracting this over here. We're left with velocity initial 1 minus velocity initial 2 equals velocity final 2 minus velocity final 1, which is essentially this equation right here.